All right, so one more lesson before our test. Remember, your test review is in the folder, although I've started working all the problems again this morning, like on the version that I gave y'all, and I've already found a mistake on number 1. So I'm going to fix that during lunch and re-upload it. But if you get to number 1 and you're like, oh, that can't factor that, you're right. So if you print it off before I fix it or whatever, you can always just fix it on your printed copy. Don't feel like you have to go do it again. Because there's nothing that's like glaringly horrible. It's just when I move things around, exponents disappear, and it just drives me nuts. But anyway, so we're going to look at polynomial sign charts and inequalities today. So you may have already seen one of these and not really know what it was, because when we were sketching polynomials in Delta Math, when they showed you how to do it, they were using sign charts for that, which we could have. We just didn't need it right then, so we didn't need to throw something else in. But sign charts are definitely important. It's something that you're going to continue to use in here and continue to use in calculus. All right, so let's talk about what they look like and what's happening here. So first we're going to talk about positive and negative intervals. So we're still talking polynomials. Okay, so if I have a polynomial function f of x, then we're used to saying, f of x equals whatever, but we can also have a polynomial inequality. So it has the general form of f of x is greater than 0, greater than or equal to, not equal to, less than or equal to. Pretty much anything that's not an equality makes it an inequality. So when you're talking about f of x being greater than 0, anytime you talk about the value of the function, you're talking about the y value. Okay, the value is the y value. So when f of x is greater than 0, that's true when f of x is positive. Kind of seems like a no-brainer because that's what greater than 0 means, right? And then if f of x is less than 0, that's true when f of x is negative. So there are quite a few things that you are going to apply when you get into calculus, and what you're looking for. Sometimes all you care about is whether the function's positive or negative. That's why it's okay that we can't find the max and mins right now. Even when you have the skills to do that, you still may not always want to do that. It may not matter. It may just matter if it's positive or negative, and then that tells you things from there. Okay, so let's see what happens by looking at the graph. So it says look at the function, so it's already graphed for me, and I want to name all of the intervals where f of x is greater than 0. That means when it's positive. So my function is positive here, it's positive here, and it's positive here. And then it says I have to name the intervals. All right, well, it's positive starting from here, so I start way out here. Remember, even though I'm talking about what's happening to y is positive, the intervals I write are intervals of the domain. They're x's. So x starts out here at negative infinity, and then we go all the way to here, which is negative 3. Now, do you think I would include negative 3? What are your thoughts on that? No. Why are you saying no? Very good. Because when I'm at negative 3, my y value is 0, and 0 is not positive or negative. Now, had this said f of x is greater than or equal to 0, that's different. But we don't want it to be equal to 0, so I do not get to include that negative 3. Very good. Then I start back over at negative 1 and go to 0. Again, not including either one of those because on the axis it is 0, and that's not what we're talking about. And then I start back over here at 1, and I go to infinity. Everybody good with that? So then this says all of the intervals where f of x is less than 0, so that's when it's negative. So I'd have this and this. So then I know I'm starting there at negative 3 and going to negative 1. Again, not including either one of them. Then I start back over at 0 and I go to 1. So visually, that's what it, excuse me, what it means for it to be positive or negative. It's either in the positive y's or it's in the negative y's. My intervals, again, though, are always intervals of x, always intervals of the domain. Okay, so to create this sign chart, here are our steps, which I'll just tell you what they are, and then we'll actually go through them, and they'll make more sense. We have to set it equal to 0. We completely factor it and find the zeros, which we've been doing that. That's like no big deal. Shouldn't be anyway. We plot the zeros on a number line. Should be able to plot numbers on a number line. And then we choose test points, and shades. So I'll explain that a little bit better when we get there. So let's look at number 1. So my first says to create a sign chart. So the first thing I'm supposed to do is set it equal to 0 and factor. This part right here, these little, you can ignore that. I had covered something up with a white box and apparently I moved it, so there's weird dashes there that mean nothing. So we're going to set this equal to 0 and factor. So I'm going to do that. It's going to give me x squared and x squared. So you should be able to factor this without me walking you through it. So go ahead and finish factoring and find your zeros. Excuse me. Okay, everybody good so far? Remember, the factoring you need to be able to do efficiently and accurately. That can't be what's holding you up, from moving on. All right, so we have our zeros. So we're going to plot them on the number line. Here's what we're not going to do. We're not going to create like a real number line where we put a bunch of hash marks and that has to be even, nothing like that. The only marks I'm putting on there are my zeros. You put any more, you're probably going to confuse yourself, and they're just not necessary. So you're just kind of ballparking it. I mean, you want it kind of accurate so it makes sense. They at least need to be in the right order, but the space between them, not that big of a deal. So in this case, I wrote it like this. Maybe it would have been better for me to write it out like this, -5, -1, 1, 5, because then it's actually in the order I'm putting it on there, but it doesn't matter. As long as you can get them on there right, you're good. So we'll make this -5 out here. So make this -1. Then 1's closer to -1 than that would be to 5, but again, just kind of getting them on there. Then I'm going to plot my actual points. So here are my 4 zeros. And we think about this number line, it's really representing the x-axis. We don't need the y-axis on here. It's representing the x-axis for us is what's happening. So then the next step said to choose test points. All right, so you use the fully factored form, which is this one right here. We're going to choose test points, but we're not actually substituting them in. Like, I really don't care what the actual value is. Since all I'm concerned with is whether it's positive or negative, I just have to know what happens with the sign. So I'm going to choose something less than -5, like -6. No need to make it complicated and make it like -100. Totally not necessary. So we'll use -6. So if I substitute -6 in here, -6 plus 1 is still going to give me a negative number. -6 minus 1 is still going to give me a negative number. -6 plus 5, it's still negative. -6 minus 5, still negative. So I know that whatever the numbers are that are in those 4 little parentheses, when I multiply them together, I'm multiplying a negative times a negative times a negative times a negative. And overall, what's that? Positive. So overall, I'm positive when I'm less than -5. So then I move on to my next little interval here between -1 and -5. So I'll go with -2. I substituted in a -2 here, it's still negative. -2 here, still negative. -2 here, positive. -2 here, still negative. Overall, this is negative. Y'all understand where my little negatives and positives are coming from? Okay. Between -1 and 1, I can choose 0. 0 is nice, so this will give me positive, negative, positive, negative. And if you don't have enough room between your 2 points, which sometimes I don't give myself enough room, if you need to go vertically or whatever, just make sure you know what they are. So when I'm positive, negative, overall that's positive. Between 1 and 5, I'll pick 2. So that gives me positive, 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 negative, positive, 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 negative. Overall, that's negative. 6 would give me positive, 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 positive. So overall, it's positive. Any questions of where any of that came from or how I figured it out? Okay, so then the last step is to shade. So remember, we're thinking about this as the x-axis. So overall, I'm positive here. So here's my function's positive. It's up there somewhere. This is negative. This is positive. This is negative. This is positive. So what that tells me then is if I ask you, at 0, is your function positive or negative? Well, at 0, my function's positive. Between 1 and 5, my function's negative. Okay, don't know where the minimum is, doesn't really matter. I just know it's negative. Okay? What questions do we have? We're not going to we're going to use this to help us graph things. There's not necessarily a whole lot of application right now. I think it's one of those things that you're just going to have to trust me that this is something you're going to continue to be something you need to be able to do. Okay? Everybody good so far? Okay. So let's look at number 2. Number 2 is already factored for us. That's nice. So I already have that. I can just come up with my zeros. It's going to be -3, 1, and 5. So when I go to plot these, I'll put a -3, 1, 5. And I'll put my points on there. It's already fully factored for me, so that's nice. That's where I'm going to put my test points into here. So if I start with a -4, right, something over here, -4. So -4 minus 5 is still negative. -4 minus 1 is still negative. -4 plus 3 is negative, but I'm going to square it, right? So that means it's going to end up being positive. So because this one is squared, my third sign every single time is going to be positive because no matter what I put in there, I'm getting a positive number out, right? So this overall right here is positive. Between -3 and 1, I can go with 0. So 0 will give me negative, negative. This gets squared, positive. Overall, it's positive. Between 1 and 5, I can go with 2. So that would give me negative, positive, positive. Overall, I'm negative. And then if I choose 6, that'll give me positive, positive, positive. Overall, I'm positive. So then I'm going to shade. Positive, positive, negative, positive. So if you were thinking on number 1 that, oh, look, they just alternate, positive, negative, so I don't need to do all that. They don't always alternate. But you do know some things about this. This doesn't alternate right here from positive to negative. It does here, but these two are the same. From what you know about polynomials and what we've done so far, what's happening at -3? A bounce. Because if I was going to graph this polynomial, this right here tells me it's a bounce. I can actually draw, I know it's so much about this, just looking at this, that I could actually sketch the graph. Okay, because here, I know that I'm going to start up, right? So I have to start positive. I'm going to bounce right here, come back up to positive. I'm going to pass through here so that I'm negative, then I come back up and I'm positive. So if I wanted to sketch that in, it would look something like this. Though my hand's always in the way. Come down, I'm going to bounce. So just from my sign chart, I know that this is an even powered function with a positive leading coefficient, right? And I can double check myself. Oh, look, this was 2, 3, 4, yep, and it's positive. Looking here, my end behavior is up, up. So again, it's an even degree, right? It is the leading coefficient positive or negative? Since I'm up, up, it would have to be positive, right? And it is. Okay, so you can use this information to get your sign chart. You can use the sign chart to help you with other information. Kind of goes both ways. Okay? What questions do we have right now? Okay. Now, the only thing you have to do right here is come up with the sign chart, even though I drew that in there, and then it's fine if you did, but just showing you how it all works. Because the next thing you're going to be asked to do is to graph it from the sign chart. So instead of giving you the function, all you have is the sign chart. And the way they have it shaded with if it's positive or negative, but I prefer above and below. So I'm going to go back in and shade this. We've got positive, negative, positive, negative, positive, right? So since I am sketching the graph on the x-axis here, I am going to make my little hash marks. This goes out to -6. So I think I'll go to 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, then I'm going to plot my zeros. So I'm here at -6, -4, -1, and 1. So I'm getting those from here. The sign chart does not tell me what my y-intercept is. It does not tell me what my max and my mins are, but I do know when my function is positive and negative. So I also know from this that my end behavior is up, right? So it's an even degree with a positive leading coefficient. So I know that I start up here, and there's no bounces. I just go up, down. So I'm going to come here, go up, down, up, like this. My function looks something like that, just from my sign chart. These are not necessarily even. I have no idea what it actually looks like, but the shape itself should be similar. Okay. What questions do we have? All right, you try and do number 4 on your own. So tell me, what is happening on the graph at 3? A bounce. Okay. So I'll tell you, last period, like I said, I asked that. Yes, it's a bounce. I knew I was bouncing negative, so it's going to have to come up like this. And then because I was talking, whatever, when I started to draw it, I came like this. And then when I went back, I was like, oh, I'm not going to be able to bounce there like I'm supposed to. So I kind of caught myself while they were telling me that I wasn't paying attention to my end behavior. Because my end behavior here, it's down and then it's up, which means this is a what kind of degree? Even or odd? Odd. And is the leading coefficient positive or negative? Positive, very good. So I would start from down here, come up, I have no idea what my y-intercept is, come back down, bounce, then go back up and stay. So something like that. Okay. Everybody okay with all that? Any questions at all? Okay, if we can do all that, we can do the inequality stuff. So to solve the polynomial inequality, we do the same thing we just did for creating our sign chart. Except for on step 3, when we plot the points, we have to make sure we used opened or closed points depending on what the inequality is, whether it says it's equal to or not. And then number 6 is to write the solution to the inequality, like when is it greater than or equal to, that sort of thing. Okay, so let's look at number 5. So the first thing I have to do is set it equal to 0, but I'm not really setting it equal to 0 because it's an inequality, but put 0. Move this over, basically, in factor. So I'm going to get x to the 4th plus 4x cubed minus 9x squared minus 36x is greater than or equal to 0. Okay? So you go ahead and factor that and find your zeros without me talking you through it. So did I give you enough time? Did you get these zeros? Okay, so on this one, we have to make sure that we're paying attention to this sign right here, okay? Because it's giving me two pieces of information. First of all, it's greater than or equal to, which means I'm going to put closed circles here. And then the second thing is when I actually give the intervals, which is part of this, since it's greater than or equal to 0, we're concerned with the positive. Like we do the whole thing, but then in the end, when we give the intervals, we're giving the positive intervals. All right, so then, and this is the fully factored form that we are looking at here. So I'll substitute in a -5. So this is negative, 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 negative. So I have 4, negative, 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 negative. Positive overall. Okay, so see if you can do the other ones and substitute those in and see what happens. See if you can come up with your signs here. Here I'd have to use a -3.5, right? So do y'all agree with my signs? If you do, then you can go ahead and shade as well. So positive, negative, positive, negative, positive. So since this is an inequality, we have to actually solve it. So this, we have this sign chart, and the sign chart's important for us, but it's also going to tell us when our function is greater than or equal to 0. That's all of these, right? So my intervals, and going to start out here at because remember, they're intervals of x, even though we're talking about y. I'm going to start at -infinity. I'm going to go all the way to -4. Do you think I get to include -4 here? Yes, because it's greater than or equal to, so I get to include negative 4. Then it's a union with, I start back over at negative 3 and go to 0, and I get to include both of those. And then I start back over at 3 and go to infinity. So there is the solution to my inequality. What questions do we have? Anything at all? Okay. All right, so then number 6, I'm going to set it equal to 0. So 3x to the 4th minus 11x cubed minus 4x squared less than 0. So go ahead and factor that. Find your zeros. See if you can get the chart done. All that good kind of stuff without me talking you through it. Do we have our number line? Yes. So on the number line, when I go to put my points, am I going to put open circles or closed circles? Open, because this is just less than, okay? Which means it's open, and since it's less than, it's going to be negative. But I put open circles here. And again, this is the function I'm looking at to test my points. So I can do, from the negative 1/3, I can do negative 1. So negative 1 squared, that's going to give me positive every time. Negative 1 here is going to give me negative and then negative. So overall, this is positive. I need something between 0 and negative 1/3. What do you think I could use? Is 1/2 less than 1/3? Yeah, I know. It's okay. Okay, if I can't use 1/2, what could I use? What's half of 1/2? 1/4. Okay, so we'll use negative 1/4. So if I have negative 1/4, that's going to be squared. It's going to be positive. Negative 1/4 right here would give me negative 3/4 plus 1 would be positive. And then that would still be negative. So overall, that's negative. So I'll go ahead and finish the sign chart. Do we agree with this? Yes? Okay, so then I have to answer it, right? I need to put the intervals where it's negative. All right, so I know it starts negative at negative 1/3. At negative 1/3. Do I get to include the negative 1/3? No, because it is an open circle. Nope. So I'm negative. Do I get to go all the way to 4? Think about your circles. At 0, am I positive or am I negative or what am I? What happens when x is 0? What's y? 0, right? So when I'm 0, am I negative? No, so I don't get to include it. So I go negative 1/3 to 0, start back over at 0, and go to 4. And I don't include any of it because I have open circles. Now, had this said less than or equal to, then I could have had one interval going from negative 1/3 to 4, because then I could have included that 0. Okay. What questions do we have? Anything? Okay, awesome.